This is the final step of the course project. And what we are going to do is to use the potentiometer class inside the traffic light class so we can modify the brightness of the LEDs while the traffic light system is working. So I am going to come back to the main file just a little bit later, and we are going to start with the first thing, which is to add the potentiometer in the traffic light class. So I go to the header of the traffic light, and now I'm going to include potentiometer.h. And by the way, I'm also going to include Arduino.h. Because I also use functionalities of Arduino in this traffic light class. Okay, I use the time functionality and all of those functionalities here. So that's not a bad thing to add this header here, just in case. So we have the potentiometer header. Now in the private attribute, I'm going to add yet another hardware component. So potentiometer, let's call it potentiometer. Okay, and now in the constructor, so I have my 3 LEDs, the LED blinker, the push button. I'm going to add another parameter, which is potentiometer, with the reference here. Okay, so we pass the potentiometer as a reference, and then, well, for now we don't need to change anything. Let's go to the trafficlight.cpp, change that method here because this is not correct anymore. So let's just add what we added here, potentiometer. Okay, and let's do this. Potentiometer is equal to potentiometer. So it's quite easy now. Okay, you just add a new component as a private attribute, and then you add a new parameter in the constructor, and you do just this potentiometer is equal to potentiometer. Now the potentiometer doesn't have an init method here, so we are not going to call init in the init method of the traffic light. Okay, and the next thing I'm going to do, I'm going to go back to trafficlight.h, and I'm going to add another here private attribute. Let's add it here. It doesn't matter the order. Let's say byte brightness. So actually LEDs brightness. Okay, in the traffic light system, we are also going to get the value from the potentiometer and update this attribute, this variable, which will contain the LEDs brightness. And from that attribute, then when we power on the LEDs, we are going to be able to pass this LED brightness as a parameter. Great. And we use byte because, well, the brightness that we need to pass for the LEDs needs to be between 0 and 255. So this is a byte, okay? This is what we are going to give to the analog write function that we are going to see later. And so to update this attribute, I'm going to add a new method. Let's add it as private also. Void update LEDs brightness. And I'm going to implement that method in trafficlight.cpp. So let's go here just before the update. Let's add traffic light. And how do I update the LEDs brightness? Well, so I'm going to do LEDs brightness is equal to, so I get the value from the potentiometer first, potentiometer dot get value, and this value is between 0 and 1023. So basically the max value is 4 times bigger than the max value of a byte. So basically what we need to do, we need to change the range. So from 0 to 1023, we need to change that range to 0 and 255. Okay, so great news, we start at 0 for both, and now this we need to switch to 255. So basically we need to divide the values here by 4 to get this range. So that's quite simple. Now I do divide it by 4 and that's it. I get the value from the potentiometer. I divide it by 4 and this becomes a value between 0 to 255 approximately. And I put this in LED's brightness, which is a byte data type. So the value will be correct when we pass it to the LEDs. And now that I have a method to update the attribute LED's brightness, I'm going to call this from the update of the traffic light just here. So every time I enter the update, which will be very, very frequently, I also update the LED's brightness attribute. And I am also going to add this here in the init. Let's just add there. Okay, so we don't start with an unknown LED brightness. We start with a value that we know in the init. Okay, so we initialize the value in the init. Just like we kind of initialize the state to red, here we initialize the attribute. And now, well, we have the potentiometer which is working. Inside the traffic lights class, we update the LED's brightness. And what we need to do now is we need to be able to tell to the LEDs that we want to put this LED's brightness. Okay, when we do, for example, yellow LED on, this is going to do digital right with high, which is going to put full intensity on the LED. What we want is to be able to give another command. So instead of just on, it gives the value here, LED's brightness, that will apply to the brightness of the LED. And I'm going to go to the LED class and I'm going to add a new method here. So here we power on the LED with on, and on is going to do, as you can see, digital right. What we want to do is to do analog right with the LED's brightness. So I'm going to add void on and byte brightness. So this is an overload of the on method. So now we can call this without any parameter, or we can call this with a parameter. So of course now I need to implement that method like this, LED, and I put this of course in the LED class because this is a functionality specific to the LED, right? So when I do on, I'm going to do state is equal to high also. Okay, because we need to know the state. For example, when we do toggle, okay, LED is powered on, we need to know the state. So we're going to say that when we use on with the brightness, whatever brightness we give, we are going to still say that the state is high. And now analog, right, pin, and now brightness. So very simple, instead of using digital right, we use analog right with the brightness that we got. And here it's very important that the LEDs that you have on your circuit should be connected to pins that allow PWM functionality. And that is the case in the circuit I have shown you. We have LEDs connected to pin 9, 10 and 11 of the Arduino Uno. And those pins have the PWM functionality. If you use a pin that doesn't have PWM, when you do this, it's not going to work as expected. Okay, you may see the LED powered on completely or powered off completely, depending on the value you apply here. Okay, if it reaches a certain threshold, it's going to do simply like digital right, or if it's below this threshold, it's simply like digital right but with low. So you might still see some LEDs powered on, but it will be either full intensity or zero intensity. Okay, so if you don't want to have weird behavior, make sure that when you use this method, you use this on an LED that is connected to a digital pin that accepts PWM. Okay, and now that we have this, let's go back to trafficlight.cpp. Now we have a simple way to apply the LED's brightness that we have and that is updated very frequently, is simply when we do red, yellow or green, instead of simply on, I'm going to do on LEDs brightness. Okay, I simply pass the LED's brightness that I have to this method. So now instead of using the simple on, we use the on with the brightness, which is going to do analog right. So let's go to the CVP file and do the same thing here and the same thing here. And that's pretty much it. So what's going to happen here is that we update this very frequently. And then so the update method is called very frequently. So the switch is also going to be executed very frequently. So in the switch, we do red, yellow, and green. And when we call those methods, it's going to apply the new LED brightness. Great, and now let's go to the main. And so we have our potentiometer already here, but this potentiometer is not yet in the traffic light class. So I'm going to add here potentiometer. Okay, so now the constructor is correct. And I'm going to go back to this in the setup. I'm going to remove the serial begin. So traffic light init, that doesn't change. I'm going to remove this. And traffic light update, that doesn't change. So we still have 2 lines of code. I'm going to see if that compiles. Okay. And now we can test this final step directly on the Arduino board, and I'm going to upload the code to the Arduino board. Okay, you can see the LED now, the red LED is powered on. So what I can do now is with the potentiometer, as you can see, I can modify the brightness of this. So this is the max brightness. I'm going to put a lower value here, like this. And I'm going to press on the push button to initiate the sequence. You can see the brightness of the LED now is a little bit lower. And when it blinks, actually, this is the full brightness. But when we have the states for the red LED, or the yellow LED, or the red or the green LED, the brightness is lower. I'm going to do that again, and I can change, as you can see, I can change the brightness directly when I execute the traffic light system. So great, it's working as expected. We have added the complete functionality in the traffic light, and the only thing we needed to do is to just add the potentiometer here in the constructor, and the code here in the main didn't change. And well, congratulations, you have just finished the course project. And as you can see, we have quite a few files here, but everything is clearly organized. So it will be super easy for you to add new functionalities, to modify some functionalities, etc. And as you can see, for example, on the led.cpp, we just have 50 something lines of code, 30 on the led.h, and the biggest file is the trafficlight.cpp, which contains 106 lines of code, which is not that big, okay? And well, the code is clean, it is clear, it is easy to read, okay? You have a clear public interface for each class so that it is easy to use. And as you can see, it's very easy to use in the main file, okay? We create the objects and then we simply do, for example, init and update for the traffic light. So that's super easy to use. So now what you can do, go to the next section, the conclusion section, and make sure that you watch the improvement ideas for this project, because of course you can always improve a project, and also get a recap of the best practices when writing OOP code for Arduino.